All right, so word problems. Okay, so all the quiz is word problems. Okay. Um, this right here says solve these system using any method. I give you almost no space. What method would be the method you would prefer? Desmos. Okay. So I'm kind of expecting it. When you use Desmos, you just give me an answer. With these questions, we're supposed to list the variables. You got to give me the system, and then you got to give me an answer. So, in other words, you're kind of doing these in Desmos. Question? Okay. So, word problems I think are really tricky when you have different kinds and you don't know the difference. So, I've given these all a name. Okay. Let's go ahead and close Chromebooks. Um, Ask me after notes. We can kind of figure ballpark it. So this first one, here, one big hint with the system, how many equations should you get? We need two equations. We cannot solve it without two equations. The second thing is usually in the question, meaning where the question mark is, identifies the variables that we want. Okay? So if I were to not read anything else, but just read the last sentence, how old is Ian and Cole? What do you think our variables are? Yeah. I and C, and what do those represent? So Ian's age and Cole's age. Okay. So in all of these problems, I say you have to tell me what the variables are. Boom. That step's done. Then we have to write our system. We have to have two equations. A lot of times the equations, one equation comes from one sentence, the other equation comes from the next sentence. Ian and Cole's sum of their age is 61. Can you write an equation from that? I'm listening. Yeah. Go ahead. C plus 1. Close. Or not 1, I mean I. Right. And I don't know why, but I feel like I need to just do I plus C, though what she said was totally right. I plus C is 61. Ian is 5 less than 5 times Cole's age. What does the word is mean in math? Equals. This is saying I is. Ian equals 5 less than 5 times Cole's age. Good. One thing that a lot of people want to do is they want to write it in the order that it says, but we kind of want to put that 5 less, which means to subtract 5 after we do 5 times Cole's age. So 5 times Cole's age minus 5. So now we have a system. Have I showed you how we write this symbol for our system? Okay. That's this little curve thing, and then a point, and then a curve. It's like a C, and then a point and a C all connected. That's how we represent that. That's our system. Can you do it on the other side? Nope, just it's on one side. That's a good question. And then I don't say solve any particular way, so I go to Desmos, and I think it'll let me use I and C. It doesn't like it at first. It doesn't like it at all. So I'm going to go ahead and keep it in order, X and Y. And then that means X equals 5Y minus 5. So there's my system. I zoom out. This one is all the way up here at 61, but I can click on this, and it says 50, 11. So then we write our answer to our system. I can go back to my notes. I expect you to use Desmos. Okay. And then 50 comma 11. So we got to make sure we have them in order, right? So this was my I and this was my C. Word problems get word answers. Ian is 50 and Cole is 11. I'm sorry? Because Ian is my brother and Cole is my son.
Wait, is that like really true, like the name? Oh.
Yeah.
I was like, oh, because I know when I was little, my dad was just.
What?
Wait, actually, I thought it was just you made this.
Yeah.
You were like, how
For some reason, he doesn't make.
Yeah. I wrote these ones.
My mom just turned 45.
So that type is, I call those, I don't know what to call them, but when they give you kind of just this kind of equation that one is something more than the other or somehow different than the other. So let's try another one. And a lot of times they're kind of the same. So this one, two numbers sum 268. Again, let's read the whole thing and then I want to go back to the end. But two numbers sum 268. The larger number is 13 larger than 14 times the smaller number. What are the two numbers? So I like to start. What are my variables that I want here? Yeah, L and S. And because Desmos, for this one, you can use whatever variables you want, and I won't mark it wrong. But I'm going to go ahead and use X and Y because I know Desmos likes that a little bit better. And there's really no, I'm going to say one number's this and one number's that. So it kind of doesn't matter. Okay. So X is the first number, and Y would be our second number. Because that's what we're looking for, or what are the two numbers. It doesn't even say like put one, the bigger one first or anything like that. Okay, can we close Chromebooks? All right, so the two numbers sum 268.
So
268 equals X plus Y. And I usually like to write the variables first, but if you wrote it the other way, that is totally fine. The larger number is, okay? So let's go ahead and go ahead and identify this as the larger. We'll make X the larger. The larger number is, so X is 13 larger than 14 times the smaller. So we usually like the adding or subtracting on the end. So 13 larger, yeah.
X equals 13y plus 13.
Yes, X equals 14 times Y plus 13. Even though they say the adding or subtracting first, I like to put it on the end. And there's my system. And then we just simply go to Desmos. Okay. I don't expect us to do any solving on these. We just let Desmos do that work. We get 251, comma 17. What are the two numbers? It doesn't ask you which is the larger or the smaller. Word problems get word answers. The numbers are 251 and 17. And I don't know about you, but that's a super easy check. If this is a test, I can go 251 plus 17. Does that give me 268? It does. If I do 14 times the smaller plus 13, does it give me the other one? And it does. Okay, so that's a pretty easy, quick check. So those are the type where one number is bigger than the other or something like that. That's what I call those. These are the ones that generally will set people off the edge. Okay. These are the ones that people will say and will get really confused about. Okay. So, but they're called against the wind or with the wind. Okay. So that's wind or current. What does going against the wind do?
It makes you slower.
Makes you slower. Okay. My wife and I went on a bicycle ride in Hilliard, and it was like out in this cornfields, and went through Hilliard, and we went like 4 miles, and we're like, wow, this is like we're like really good at riding bikes, like we're awesome. And then we turned around and we realized it was really windy, and we didn't kind of know,
So,
and it was really crazy hard
yeah,
going back.
I do that sometimes when it's
Yeah.
going too slow. I'm against it.
Yeah, or in my neighborhood, we had this. Most of the roads are downhill, but very slightly, so you don't really notice it until you turn around, huh?
You guys have motorized bikes?
Yeah.
So like,
Now we do.
oh, okay.
We learned our lesson. So, anyways, the wind. When you go with the wind, it's going to do what to you? Speed you up, and when you turn around, slow you down. Okay. Another type of problem, current. What is current? Where does current live? It's in water. Current has to do with water. Have you ever gone down a river in a boat? Okay. Anybody ever gone in a? Okay. So like you get on the canoe, Trapper John's, or whatever, the kayak. What do you do when you get to down the river? You stop and you do what? Do you turn around and go up the river?
No, you get on like not a truck. It's like a.
You get in the van and they throw the boat in the back, and then they take you back up because it's so hard to paddle back up.
We went rafting, and our tour guide tricked us on that one. But we were going down. He was like, "Yeah, we'll loop around to the entrance and get back on." And we're like, "Oh yeah, that makes sense." Then we forgot the river is the circle. And it starts and it goes all the way down, and we have to end up somewhere else.
Yeah.
But when we got there, they got in the van and we went back. It was twice as long on the van because we were so far away.
Yeah. Yeah. So it's hard. And what happens if the river is faster than you can paddle?
Then you just
You go backwards.
yeah.
Will you ever get back? No. Okay. So that's what we're talking about. The wind or the current is either going to help you or it's going to hurt you. Okay. Amanda, that's my wife, takes her boat on the river each week for a trip. Last week, she went downriver at an average speed of 26 miles per hour. When she came back up the river, her speed was 18 miles per hour due to the current. Okay. So she's not paddling. It's a motorboat, right? Okay. What is the speed of the current? What is the speed of the boat in the still water? Those last two sentences are huge hints on what our variables are. Can someone guess what one of our variables is? Speed of the current. So I'm going to go ahead and do C for speed of current. Okay. Someone want to guess the other variable? Yeah.
The speed of the boat.
And what letter do you want to use for that?
B.
Good. I like B too. B, so it's the speed of the boat in still water. And what that means is there's no current. It's not being pushed or pulled or slowed down or sped up from that. Okay? All right, so distance equals make sure I don't mess this up. So last week she went downriver. Okay, if she's going downriver, what is the current going to do? Faster. So the speed of the boat plus the speed of the current makes her go 26 miles per hour. She then turns around and goes upriver.
Wait, so would it just be V equals something
On the second one,
for speed of the boat? It's still one. Or
okay, yeah,
B minus C equals 18.
yes, and then she turns around and B minus C equals 18. Okay, so I go to Desmos. Will it like B and C if they're both in?
yes.
I never know when it's going to like it when it's not.
B and C is like close to each other.
Oh.
In the alphabet. So that's just what we have like four.
Desmond told you that?
Yeah. See?
Nope.
It said no.
No, wait, go back and like put a space, like at 26. No, the other part. Go to the end, like at 6,
Just change.
and then put a space. God, that usually works for me.
So we're going to go ahead and do X and then Y. Okay, and then we can go over here. We can click on this and we get 22 comma 4. And I don't know about you, but it's pretty obvious which one has to be faster, the boat or the current. Try that again. Which one's got to be faster? The boat. Okay. The current can be faster, but if it is, you're going backwards. You can't. She couldn't go back. Word problems, word answers. The speed of the boat in still water is 22 miles per hour, and the speed of the current is 4 miles per hour. Okay. That's kind of against the wind, with the wind, current, whatever, kind of a simpler one. This next one's a little bit more complex, but same concept. Yeah. They're all different types. So we want to make sure we get see all the different types. Bob flew. Bob's my father. Bob flew in a plane across the country. This trip was 700 miles. It took 2 hours to fly there. When he came back, it took 2.8 hours because he was flying against the wind. What is the speed of the plane in still wind, and what is the speed of the wind? What are my variables? Huh? Yeah.
Where'd you go?
On this trip,
You just looked this up.
I made it up.
What if
Yeah.
Speed of the plane is still in speed of the plane. Or speed of the wind.
Yeah, so speed of the plane. Okay, and still wind. If you don't say and still wind, I won't take off. That's kind of annoying. I'm going to go ahead and give that as a P. And then speed of wind. We'll go ahead and W.
Would it be easier to like put these in, put the hours in like minutes? Would it be easier to do that?
As long as everything is in the same thing, it's fine. If I said it took 60 minutes and I said 2.8 hours, then you want to convert them. But if they're all in hours, life's good. Okay. We have to know a formula that the formula is distance equals, does anyone know this formula from science?
Isn't it like speed time?
Yeah, close. We would say rate, which is speed, times time. Okay. This is speed might even make more sense to us, but that we use the word rate in math. Can someone give me one equation? Yeah.
What, I'm just gonna guess, would it be 700 equals 2x plus 2.8y?
It is not. Let's talk about the first trip.
700
So on the first way, he traveled for 2 hours. And what was true about the plane and what was true about the wind?
T plus there was no wind.
There's always wind.
Sorry. He was going down there. The plane was going with the wind. Oh yeah.
Okay.
That's right.
How long? Go for it.
700 equals W times 2.
And
Is that it?
let me ask you this. How long did the plane fly for?
2 hours.
How long did the wind affect the plane?
2.8.
2 hours. Did they help each other or did they hurt each other? Help each other. So this is not how I would write it, but you could almost, I'm going to cross this out here in a second, but you could almost say that the plane flew for 2 hours and the wind helped it for 2 hours. We typically rewrite this as
I like the other way better.
the first way. Let's go with it. There's no reason we can't do that. I would absolutely accept both. So for 2 hours, the plane flew, and for 2 hours, the wind helped it.
Oh.
Make sense? And then the trip back. How long was the trip back? How far was it? 700 equals. How long did the plane fly for? So 2.8 P minus 2.8 W. Yeah. You don't have to do anything. We're just going to now throw it into Desmos.
I thought you would have to divide everything by 2.
You could, if I said solve this, you could do all kinds of things, but no. Write an equation, throw it into Desmos, okay? So we go to Desmos and we have 2 and 2 equals 700. And then 2.8 and 2.8 equals 700. We got 350. You knew that? You could do that in your head? Good. So 350. What has to be the plane? 300. Okay. So the plane speed is 300. Does anyone know what the units are going to be? Why is it miles per hour? Because it's in miles and it's also in hours. And the wind speed is 50 miles per hour. And this is a real thing. I always forget, but I know that flying one way, I think it's flying to California takes longer than flying from California because of the wind. Okay?
That's great.
Yeah. All right. So those are with the wind, against the wind. These were one number's bigger than the other in some way. Then we have this type. Well, I call it ax plus by equals c, but really what is that? They're a standard form, okay? So again, I won't tell you what type they are, but once you identify the type and you know how, then it kind of helps write the equations, I think. We took two types of buses on a field trip. On the trip to the art museum, we had two small buses and three large buses completely full. We took 78 students to the art museum. We took 102 students to the crew game. We had 5 large buses and 1 small bus. How many students fit on each type of the bus? So let's start with our variables. What are our variables in this problem?
X and Y.
Okay. I'm starting because of Desmos. I'm not really against X and Y. I kind of like the other, but Desmos definitely likes X and Y better. So what would X be? Okay, how many students fit on each type of bus? So give me an example of how I would answer this question.
You do 2 equations, one for each like field trip.
Okay, we're gonna do that, but you're ahead of us. I wanna do what are my variables here? What am I looking for? Is that a hand or a stretch?
Like if X is the amount of small buses and Y is the amount of
Yeah. So amount on small buses, and this is amount on large. Okay, so those are my two variables because they're asking how many can fit on each type. So we go back, and usually, like I said, we read until we think we have an equation. We took two types of buses on one trip. We took 2 small buses and 3 large, taking 78 students. What's the equation there? 2x, good.
Plus 3Y equals 7.
Yep. We have to have 2 equations. The next one says we took 102 students to the crew game, 5 large buses, and 1 small bus.
5Y plus 1X.
Good. 5y plus 1x equals 102. So that's where the variables can cause us some problems if we're not careful. Because that second one, they said 5 large. And we already decided the large was the y. So there's our system. Go to Desmos. It likes that we put it in x and y. 5y plus 1x equals 102. 12 and 18. So 12, 18 is our answer. Word problems, word answers.
12 students for each small bus and 18 for each big bus.
Okay. The small bus holds 12 students, and the large bus holds. No. Yeah, I actually wrote this problem, so I don't know. It should be, it's my fault.
It's all your fault.
Thank you, I appreciate it. For sake of time, we're going to set up the next one and then not finish it. Okay. The band played 2 different shows. The first night, 62 adults and 20 student tickets were sold for $380. The second show, 75 adults and 35 students for $497.50. How much does each type cost? What are the 2 variables here? Yeah. Okay, do you want to use X and Y or do you want to use S and A?
X and Y.
Okay. It doesn't matter. So student tickets could be our S. And I got to be very careful when I do that. And adults can be our A. Because we're just going to set this up because we're going to run out of time. Can somebody give me one of the equations? Yeah, Brody.
62x plus 20y equals 380.
Good. Can somebody else give me the other equation?
I thought you, is that an S?
That is an S.
I thought you said you didn't do S's.
I don't usually, but
Why don't you just put a
I was bullied into it.
That's kind of like a why don't you just put a parentheses around it?
What if I do like,
Put like a
Money sign?
parentheses around it.
yeah, I thought about making it a money sign. How about that?
Oh yeah, just do
Does
that.
that make you happy? Yeah. You got the other equation?
35x plus 75y equals 497.5.
And we're talking different variables, but that's fine. I was consistent on mine. We just got to be careful that whatever we assign X, that we're consistent. Okay. Throwing into Desmos should spit out an answer. Okay.
Can we use a money symbol with the decimal?
I don't think so. I'm always kind of baffled what works and what doesn't work in Desmos. So, all right. So these ones I call the other. Okay. So we have to be able to just kind of realize that there are two equations, just kind of try to figure it out. My friend went up 504 steps to the top of the building. He started walking down at a rate of 60 steps per minute. I just got to the building and carrying a very heavy box. I started walking up the steps at a rate of 12 steps per minute. How long will it take us to meet? How many steps from the ground floor will we be? So what are our variables here? Yeah.
The rate of the friend walking down.
Okay. So that's now I see what you're saying, but that's not one of the things we're trying to answer.
Oh, how long will it take to meet?
Yes. So what would that be?
Like their intersection.
Right. But what is that variable?
Oh, x.
What is it? X is what?
X or L
For what?
for like how long it takes to meet.
Okay. So what is that? Time. X can be time. And then how many steps from the ground floor will we be? We're using Y. What is Y going to represent?
Steps per minute?
Nope. Steps from where?
Step
From the ground. Okay. Steps. Actually, what is it? What would be? What do you call that? It's a distance. What do you call it when it's a distance that goes up?
Elevation.
Yeah. Or
Well, I'm sure.
I think I just heard it.
Yeah.
It's our height. It's our height in steps. Okay. My friend went up 504 steps and starts walking down at 60 steps per minute. Can someone write an equation for that? Yeah. 60x.
plus 540?
No, 60x equals 540.
It's not that. What are we doing?
Going down.
We're going down.
It'd be Y equals 60x plus 540.
Yes, y equals how high we're up, 540 minus 60x. How high is he after x time? Then the other one, walking up the steps. What's that equation? Brody? Y equals 12x.
And then for sake of time.
Okay, we're going to leave that one. I don't want to, I want to make sure we'll come back to it for a time. Okay. Coins. I have 95 coins that total $7.35. I realize I only have dimes and nickels. How many of each type do I have? Okay, variables. So let's go through the step. First, list what our variables are. Yeah.
D and N.
Okay, D and N. What does D represent?
Dimes.
Tell me more.
10 cents.
Not 10 cents. Dimes are 10 cents, but what does D represent?
Dimes.
Amount of dimes.
Amount of dimes. What does N represent?
Amount of nickels.
Can someone give me one of the two equations? Yeah. Okay.
What else should get that? 7.35 equals.
Okay.
What did you
All right.
I have a different equation.
Sure.
I did 95 equals G plus N.
Okay, we have 595 coins. So this is just a number of coins we have. I don't care how much the coins cost. This is just how many coins I have. How do I, when I care about how they cost, what do I write there, Brody?
0.1 D and 0.05 N.
And I'm doing what with them?
So plus
Adding.
Adding them.
that's what it's called.
Okay, so one of them has to do with how much value they have, and the other one is just how many coins I have.
Can we solve this one?
Sure. So I go to Desmos. Anyone know if it's going to like the D and the N?
He told me
It's not good.
It's not going.
So I'll do X. Desmos told you.
Other equations in there.
knows?
Yay.
Have you ever heard that song, Desmos is my girlfriend?
What?
That's is your girlfriend?
Mm-hmm.
Wait, is she not your wife?
What?
Is she not your wife?
No. All right, 52.
Your wife's the creator of
Desmos is my girlfriend. You guys know that song?
That's what it is, dude.
Who made this?
You're assuming it's gender, bro.
Exactly. You can't do
Yeah.
You can't do that in this day and age.
Word problems get word answers. So the amount, so I have 52 dimes and 43 nickels.
Yay.
Got to be careful with the variables. If they switch on you, you got to make sure. So it might even be better because we're using Desmos to use X and Y. So when I'm doing these problems tonight and you get kind of lost, ask yourself, Mr. McConnell is such a nice and wonderful teacher that he's given you every single type.
Yay.
Look at the question and try to say, I think it's this type, and that might help you set up the equations. The hardest part is writing the system. Okay? Identifying the variables and writing the system. I think this is one of those quizzes, or this is one of those group quizzes that if you don't have it done, you're probably going to run out of time tomorrow. Okay?
I'll get it done.